In section 1.7, we're going to look at solving equations with variables on both sides. So this is like one of the last things that we need to do in our work solving linear equations. So some equations have got variables on both sides of the equal sign. And to solve these, what we say we want to do is collect the variable terms on one side of the equation. So we look at all of the x's and we want to get them all on the left or all on the right side of the equation. Now this is just a suggestion, but it's a really helpful one. We want to move the smaller of the two variable terms. When I move the smaller of the two variable terms to the other side of the equation, it helps to keep things positive, which is kind of a benefit because dealing with negative things always tends to throw a little wrench into the works. So it's just something that helps keep the equation a little bit nicer for us. So we're going to try to move the smaller of the variable terms. So let's look at a couple of examples here and determine which is the smaller of the variable terms. So this equation, we have 9x minus 19 equals 2x plus 3. So which is smaller, 9x or 2x? Obviously we want to look at the coefficient. 2 is smaller than 9, so 2x is the smaller variable term. In the second equation, we have 3 minus 6x is equal to 2x plus 5. So looking at your variable terms, we have 2x again, and we have 6x, but it's not really 6x, it's really negative 6x. So which number is smaller, negative 6 or positive 2? Negative 6 is smaller. So negative 6 is the smaller variable term. And let's look at the last one. We have negative 4x and negative 7x. So again, we're comparing negative 4 to negative 7. If you think about a number line, and you don't have to draw this in your notes, but a number line would go negative 7, negative 6, negative 5, negative 4, etc., etc., etc. Since negative 7 is to the left of negative 4, negative 7 is smaller, so negative 7x would be the smaller variable term. Okay, so let's look at how we might use this. Let's solve this equation for x. We have 7x plus 19 equals negative 2x plus 55. Now, previously when we've been solving equations that had multiple steps, I asked you to distribute if we needed to distribute. Do we need to distribute in this case? Nope. I asked you to combine like terms if you needed to combine like terms. So again, in this case, there are no like terms on the left to combine. There's no like terms on the right to combine, so we don't have to deal with that either. So now I'm going to say, oops, not B, but the third thing I would like you to do is move your variable. Once you move your variable to one side of the equation, then the last thing that we're going to do is undo the rest of the operations using SADMAP. Now, there certainly are variations, and it's not like you have to do everything in this order every single time. You could certainly get the correct answer another way, but this gives you a nice step. If you always do it this way, you're not going to miss anything, and it's really helpful to make sure that you're doing legal algebra, that you're not doing something you're not allowed to do. So in this example, I'm looking here, 7x plus 19 equals negative 2x plus 55. I see that negative 2x is the smaller variable term. So to move it, I'm going to do the opposite. Since this is negative, I will add 2x to both sides, like this. There we go. And when I do that, 7x plus 2x is 9x. Bring down the plus 19, and that's going to equal 55. Now I can undo using SADMAP. I can see the two operations that I have are multiplication and addition. I'll undo the addition first. So we'll start by subtracting 19 from both sides. That's going to leave me with 9x on the left. And on the right, 55 minus 19. Let's see, we got to do a little bit of borrowing here. That's going to be 36. Now we're going to undo that multiplication by dividing. So we'll divide both sides by 9, and we'll get x is equal to 4. We can plug it back into check, 7 times 4 plus 19. Does that equal negative 2 times 4 plus 55? Well, 7 times 4 is 28. Negative 2 times 4 is negative 8. And now we simplify. 28 plus 19 is 47. Negative 8 plus 55 is also 47. That's good. My answer checks. I must have done it right. All right. Let's do another one. What happens in a case like this where you have only one variable on the right side? Well, it doesn't matter. In this case, I'm going to look at this and ask myself, can I distribute? Nope, good to go there. Do I need to combine like terms? Nope, good there. So now I'm going to move my variable. So the smaller one is negative 9y. So that's the one I'm going to move. To undo a negative, I'm going to add. So we'll add 9y to both sides. When I do that, I have 80 is equal to 15y. And now we'll divide both sides by 15. Doing that is going to give me y equals, I'm not sure, let's see, let's reduce the fraction. I know each of these is divisible by 5, so 80 divided by 5 is, let's see here, 5 goes into 8 once. That leaves me 3. 5 goes into 36 times, so that would be 16 over 3. And I think that's about it. So I can't reduce that fraction any farther, so you could say y equals 16 thirds. If you wanted to, you could also say y equals 5 1/3, but you guys know I prefer the improper fraction. All right. Let's look at a case where we do have to do one of those steps 1 or 2 first. So step 1, distribute. Nope, we're good to go there. But step 2, combine like terms. Oh, we totally have like terms that we could combine here on the left side of the equation. We have 3x and we have 4x. So we want to combine those first. 3x plus 4x is 7x. So we have 7x minus 10 equals 5x minus 7. Now I can move my variable. Which is smaller, 5x or 7x? 5x is smaller, so I will subtract 5x from both sides of the equation. There we go. 7x minus 5x is 2x. We still have minus 10 on this side. 5x minus 5x is 0, and then we have negative 7 on this side. So now I can see my operations are multiplication and subtraction. We'll undo the subtraction first by adding 10 to both sides. So we have 2x is equal to negative 7 plus 10, which is 3. And look at this. Whoops, not divide by 3. How about divide by 2? Sorry. Divide both sides by 2. And we'll have x equals 3 halves. Hold on. Now I have to pause. I'm doing my video. Okay, so the last thing that we have to talk about is figuring out how many solutions an equation might have. Not every single linear equation is going to have a solution. Sometimes equations don't work. So there's 3 different possibilities that could happen. The first possibility is, like all the problems that we've been looking at so far, there's one solution to the equation. Okay, all the examples we looked at today, all the examples that we looked at in this unit up until today have all had one solution. But there's 2 other possibilities, and those are that the equation has no solution, or 0 solutions, or that the equation has infinitely many solutions. This is like saying x can be anything. I have to be careful about saying anything because it can't be anything. It can't be like an orange, but it could be any real number because we're working within the set of real numbers here. So I want to look at 2 examples that show one case where it has no solution and one case where it has infinitely many solutions. So here we have an equation. We see we have variables on both sides of the equation. That's often what's going to happen when one of these two situations arise. We're going to go through our steps. Step number 1, distribute. Oh, we do have to distribute here. So distributing the 3, we get 3x plus 6. And then on the right, we bring it down, equals 3x plus 6. Ask yourself, do you need to combine like terms? Nope, so that's been done. So now we go on to step 3 of moving our variable. Well, there is not a smaller variable term because both the variable terms are the same. So what happens when I try to move it, I end up subtracting 3x from both sides, and my variable term has gone away completely. 3x minus 3x is 0, so that leaves me with 6 on the left, and on the right, 3x minus 3x is 0, and that leaves me with 6 on the right. So 6 on the left, 6 on the right, 6 equals 6. Now this is where we can tell the difference between whether there's no solution or whether there's infinitely many solutions. 6 is equal to 6. So we say this statement is true. If the statement is true, then that means that there's going to be infinitely many solutions. Alright, so this is a true statement. We can write it using our symbol for infinity. So we can say infinitely many solutions. Or, in other words, x can be anything. Now you can test this out by plugging in different values for x. For example, if x was 1, 1 plus 2 is 3, 3 times 3 is 9. Over here, 1 times 3 is 3, 3 plus 6 is 9, so x equals 1 is a solution. You could check another number. If x was 2, 2 plus 2 is 4, 3 times 4 is 12. If I plug in 4 over here, we get 3 times 4 plus 6, or sorry, 3 times 2. I'm plugging in 2. 3 times 2 is 6, and 6 plus 6 is 12. So the left side is equal to the right side. So if there's any number at all that we can think of for x, if we were to plug it in, it would be exactly equal on the left and equal on the right. So there's infinitely many solutions. So let's look at what happens when there are no solutions. Here's the same example on the left, or it's the same on the left. We would start by distributing. So multiply that 3 through. So we have 3 times x, 3 times 2 is 6. And then on the right we have 3x plus 4. So now when I move my variable term, start the same way we did before, subtract 3x from both sides. 3x minus 3x is 0, so that leaves 6 on the left. 3x minus 3x is 0, and that leaves 4 on the right. Now I know you guys can see that 6 is not equal to 4, so this statement is false. We've eliminated all of our variables from the equation, and we're left with a statement of numbers that is false. That means there are no solutions to this equation. There is no value of x that I can plug in to the original equation that would make the left side equal to the right side. So let's take a look and figure out how many solutions are in each of these equations. And to do that, we have to just start solving. So the first one is 2x plus 1 equals 7. So here we don't have variables on both sides. We don't need to distribute. We don't need to combine like terms. So we'll start by subtracting 1 from both sides. That leaves me with 2x equals 6. When I divide by 2, I get x equals 3. I was able to solve it. Nothing weird happened. My variables didn't go away. So there is one solution to this equation. Let's look at the next one. Here we do have to distribute. So we'll start with that. That's going to give me 2x plus 2. And on the right we had 2x plus 7. I have variables on both sides. So let's move them. I'll subtract 2x from both sides. 2x minus 2x is 0, so that leaves me with 2 on the left. 2x minus 2x is 0, so that leaves me with 7 on the right. 2 equals 7. That's a false statement. So we know that there are 0 solutions to that equation. One more. 2x plus 1 equals 2 times x plus 1 equals 2x plus 2. So again, start by distributing. We'll have 2x plus 2 is equal to 2x plus 2. And if you're thinking ahead, I bet you already know what the answer to this is going to be. If we subtract 2x from both sides of the equation, that leaves me with 2 on the left, and on the right, we also have 2. 2 is equal to 2. That's a true statement. So this one is going to have infinitely many solutions. Okay, so we have 2 things that we're focusing on with this lesson. You should include both of them in your summary. The first thing is what to do when you have variables on both sides. So write a short summary of what to do when that happens. And the second thing is how to determine how many solutions an equation has. So include both of those topics in your summary and go back and write your left-hand column questions.